Okay, our standard form was the f of x or y equals ax squared plus bx plus c. Okay, and our axis of symmetry, or our x coordinate, we had a formula. It was negative b. It was negative b divided by 2a. So it was a lot of work to get our x value for the vertex, right? 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 All right, so vertex form is a lot easier. Okay, I can get the axis of symmetry in my vertex just by looking at the equation. For example, number 4. Remember, my vertex is h, comma, k. So what's my vertex? That's right, 4. Because I already have a minus sign in my equation, so I don't need to switch it. And 3. So I have 4, 3. My axis of symmetry is x equal 4, or x equal h. Now what? You could put it in your calculator. You could go to your table, get some more points. But I'll tell you right now what the easiest thing, if you're asked to graph and it's in vertex form, let's put our vertex there, 4, 3. What's our slope? 1 over 1. So if I go up 1 over 1 and do this because it's symmetric, go the other way, I got my 3 points. And look at there. A lot easier than plugging it into a calculator, isn't it? Okay, we could, if they ask you for the points on a test or a quiz, we could get that as 5, 4, and 3, 4. A lot easier than plugging it into a calculator, your calculators. Did you get caught and signed in with the party? Remind me to change the attendance. Thank you. Can you remind me later? No. Yeah, they are. I've got people taking notes. You're a liar. Okay, number 5. What's my vertex? Yep, negative 3, 7. Good, Ariana. Okay, now, are you idiots for real? You're actually playing video games, a racing game, while I'm lecturing. Okay, so I have negative 3, 7. I know a couple of transformations here right off the bat, right? Yeah, vertical stretch of 2. I know it's going to open downwards. From the parent function, I'm going left 3, up 7. Just without even doing anything. So negative 3, 7 is my vertex. Now, my slope here, my axis of symmetry is x equals negative 3. My slope is negative 2 over 1, so I could go down to, and it doesn't matter if you go to the right or left because it's symmetric. We need both points anyway. So these points are negative 2, 5. And negative 4, 5. And that's my, yeah, vertex form is so much easier. That's why, we're so used to doing it in standard form because in Algebra 1, you did literally hundreds of problems with the formula, the quadratic formula, and you did factoring. You're so used to seeing that. Algebra 2, I mean, we really like this vertex form. Questions? No. No. Yeah, ask me after. Sure, why not? All right. Number 6. What's my vertex? It should be positive 3, right? Because I already have a negative there. And negative 5. Good, Jacob. So my axis of symmetry, x equals 3. So I have 3, negative 5. I have actually, it's going to compress it. You could say vertical stretch of 1/2 at this point in your mathematical life. It's actually compressed. Okay, so let's see. I got 3, negative 5. I'm going to go up 1 over 2, up 1 over 2. See how it's compressed or wider? Because I have a fraction between 0 and 1.
Why would it be compressed?
Think of a rubber band. Okay, if this is my normal parabola, it makes it wider, so I'm compressing my rubber band. If I stretch it, see how I stretch it, makes it skinny. Okay, so that's vertex form. Easiest form in, I think it's really easiest form in math. No. If you want to go get the homework sheets, otherwise I'm going to have to assign book work. Okay, and we didn't even have a book. We're not going to read a book anyway. Alyssa, you're done. Wow. You shouldn't have even came to school. What do students not like about this form? It's hard. Yeah, it is kind of hard. Okay, what does this look like that you guys hate and you keep getting really horrible on quizzes and tests? Factoring. Yeah, you have to. You have to factor your quadratics to use this form. Okay? Now, another thing that's really kind of hard with this is to find your axis of symmetry, or your x value for your vertex. It's halfway between your two roots, so to speak, or your zeros. Okay? Now, I don't... Yeah, we did. We did solving equations where we set it equal, each factor equal to 0, right? Yeah. If not, you should have done it in Algebra 1. Okay, so number 7. Somehow this is coming back to me like I didn't teach this yet. When I have intercepts, my x-intercepts, what are my y values? What does that even mean, x-intercept? It's where it crosses the x-axis, right? So for a parabola, it's kind of unusual because if I have my x and y axis, right, I actually have 3 possibilities of how many roots or zeros my parabola can have, right? If I look at the parent function, y equals x squared, okay, how many solutions or zeros do I have? 1, okay? This is y equals x squared. So I have 1 solution where it crosses the x-axis. There's so many different words for it. Solutions, zeros. I use roots. They all mean the same thing, where it crosses the x-axis. Now, it crosses my x-axis when my x equals 0. What's the y value? No, what's the y value here? 0. Okay. where it crosses the x-axis, no matter where it crosses, your y is always going to equal 0. Okay? When we get to your calculators and we get to math modeling, next section, you are going to have to find the zeros of our parabolas. Okay, so this one has one solution. How many solutions does this one have? 2 solutions. Okay, so I could have 1 0 or 2 zeros or solutions. Again, all means the same thing. What's the third possibility? There's another possibility. I could have 1 solution, 2 solutions, many. How about none? Okay, this parabola has no solutions. It doesn't cross the x-axis, right? Now, I'm getting ahead of the ball game here a little bit, but look at our exponent here. This is the fundamental theorem of algebra. My quadratic equation has an exponent of 2. That is at most the number of solutions you can have for that equation. If I have y equals x cubed, how many solutions can I have? I can have up to 3. Okay. It's a big, huge thing in algebra if you go on. All right, so my y value here, to find the x-intercepts, my y values have to equal 0, right? Okay, so to find the x-intercepts, all I have to do is set each one of these x plus 3 equals 0 and x minus 5 equals 0. Those are going to be my 2 intercepts. So my x-intercepts are -3 and +5. So my x-intercepts are -3 and +5. So my x-intercepts are -3 and +5. Axis of symmetry is halfway between -3 and 5. What's halfway between -3 and 5? 1. How did you get that? Okay, what you're doing is you're taking -3, adding 5, divide by 2. Okay, that gives you the midpoint. Okay, so my axis of symmetry here is 1. X equal 1. My slope, 1 over 1. What's my vertex then? We know that the x value is 1. You have to plug it back in, right? So I've got 1 plus 3 times 1 minus 5. I get 4 times -4, which is -16. So here's my vertex. 1, -16. Now again, you could plug this in your calculators, but I just think it's easier to do it in your heads. Let's do another one. Let's not do another one. This math is stupid. Math sucks. Okay, what are my x-intercepts? You could do this without all this computation, right? My x-intercepts are going to be 1 and -3. So my my axis of symmetry, or my x coordinate of the vertex, is going to be 1 plus -3 divided by 2 gives me -1. So my x vertex is -1. Am I going too fast? Okay, don't forget this little minus sign out here. So I have -1 minus 1, negative out in front, -1 plus 3. Okay, what does this all equal? Well, this gives me -2. This gives me +2, gives me -4, but -4 is +4. Okay, so I have -1, 4. -1, 4. My x-intercepts, again, are 1 and -3. So here's my parabola. Easy peasy. Hey, let's do the application problem. That looks fun. Doesn't it look fun? A woodland jumping mouse can hop surprisingly long distances given its small size. A relatively long hop can be modeled by y equals -2 x times x minus 6. How far can a woodland jumping mouse hop? And how high can he hop? Right, so now, think about what we're looking for here. If we're looking for, we know that this parabola is going to open downwards, right? So it's going to have a maximum, right? That is going to represent our height. Okay, so we're going to be looking for the maximum here, and that's going to be the y value of our vertex, right? Because it's going to be opening down. So it's going to be the y value of the vertex. Now, how far can he jump? Well, if our x-axis is the ground, what are we looking for? Okay, we know it's going to be a parabola opening down. What are we looking for? Yeah, our x-intercept, right? Excellent. So, let's put this, I don't feel like doing a whole bunch of work, so let's put this one in the calculator. Grab your calculatormeters. Okay, so I've got -2/9 times x times a quantity, x minus 6. I'm going to graph this. Okay, now, if you want to tighten up the window, you could. We can get all this stuff without changing the window. We're going to do that tomorrow. So I'm going to look for the vertex. So I'm going to hit my second button, trace, it's actually calculate, and I'm looking for the maximum. Okay, so I'm going to go down here to the maximum, hit enter, and it's asking me, well, what's your left bound of this point? So I have to make sure my cursor is to the left of the maximum. So I'm going to hit enter. See how it's asking me left bound? I'm going to hit enter. Now it's asking me, are you to the right of this point or right bound? Well, I got to move my cursor over, and I'm going to hit enter. Now, you guys should get vertical lines on your calculator too. Make sure that the maximum is between those vertical lines. Then hit enter again. Okay, and my vertex, 2.99999, which is 3, comma 2. That's my vertex. Okay, 3, comma 2. Okay, so how high is this guy going to jump? I'm assuming it's feet. 2 feet. Okay, y value of the vertex. That's my maximum. Okay, now, as far as the intercept, now I have to find when my y equals 0. There's a couple of ways you could do this. You could go back to your calculate, second trace, and look for the 0, enter, and go through the same thing. Are you to the left of that 0 point? Well, yeah. Are you to the right of that 0? Get to the right of it. Yeah. And if it's between those 2 points, hit enter again, and your x-intercept is 6, 0. Okay, that's your x-intercept when y equals 0. So, it can jump 6 feet. I'm assuming it's feet. Now, this problem is what you're going to be doing for the next 2 or 3 days. Mathematical modeling. Okay. Questions, comments, concerns?